This is Geometry Lesson 1-2, Part C of the lesson. This is the last chunk of the lesson. So let's figure out these blanks. It says a postulate or an axiom is an accepted statement of fact. So much like undefined terms, it's just something we decide to be true. These are the building blocks of logical thinking in geometry. Later on, we'll get into concepts like theorems, but we will then have to prove and show that there are postulates or axioms or previous theorems that we've shown to be true that correlate to that. So our first one is postulate 1-1. It says through any 2 points, there is exactly one line. This line T passes through points A and B, and that means that line T is the only line that passes through both points. So that is an accepted statement of fact in geometry. It's a very important statement of fact, and that's what makes it a postulate. So, thinking about lines and points, intersection is the set of points the figures have in common. That's what an intersection is. In algebra, the most basic way to find the intersection of these two lines, y equals negative 2x plus 8 and y equals 3x minus 7, is to graph them and see where they meet. In geometry, we talk about this a little bit, about the intersection of lines, and this is where postulate 1-2 comes from. Postulate 1-2 says that if 2 distinct lines intersect, they intersect in exactly one point. Here you can see lines AE and line DB. They intersect in point C and nowhere else. That is another accepted statement of fact in geometry. We've got another postulate. It's postulate 1-3. It says if 2 distinct planes intersect, then they intersect in exactly one line. So 2 lines intersect in a point, but 2 planes intersect in a line. You got to think about it like 2 walls. When 2 walls meet, if you trace where they meet, you are going to make a line. So here you can see plane RST, which in mine is this light blue one, and a plane WST, which is this yellow one. They're going to intersect in that line in between them, and there's 2 points along that line that we know of, S and T, so we're going to name that line ST. When 2 planes intersect, there are definitely 2 points that they have in common. The first 2 parts of the point line plane postulate tells us that the intersection of 2 planes will be a line, and that's what we just talked about. So let's do some problems with this. Let's find some intersections. It says each surface of the box at the right represents a part of a plane. What is the intersection of the plane ADC and the plane BFG? So as we do this one, I'm going to do a lot of shading on my paper. You may want to do that as well to help you kind of figure some of this out. So we're going to first start by finding where is plane ADC. So we find those 3 points A, D, and C, and we're going to shade the plane that they're all on. If you're looking at that, that's actually going to be the top of this box right here. So that's plane ADC. And then the next one they want is plane BFG. We're going to find those 3 points, B, F, and G. It's going to be this over here. So the intersection that they want of those. Well, if there's 2 planes, we just discussed that 2 planes intersect in a line. And so you want to look and you want to find that line. Think of these as 2 walls, maybe a ceiling and a wall. Where they meet is going to be where that red and green are combined, right between that, right there. If you look on that line, there's 2 letters, BC, which means that is the name of their intersection. But because it's a line, it actually is a line segment, it looks like. You're going to write BC like that. But really, the thing you might want to be careful of is even though it looks like it's a line segment, a plane goes on forever in every direction. And so really we're saying that they intersect in a line. So make sure you add in those arrows to make it a line. The next question says, what are the names of the 2 planes that intersect in BF? So I'm going to erase what I had before and I'm going to find that line BF. BF, BF. I'm going to trace the line between them. So you want the two planes that meet there. So what you're looking at is, if you're thinking of this box as a room, that corner, what are the two walls that meet at that corner? If I look, I trace those out. Here's one in green. Here's the other in blue. And so really what we just want to do is name those two planes. There's a lot of names we could use. For the blue one, I might choose to use ABF. Remember, planes, you don't have to draw anything above them or anything like that. For the green one, I might choose BFG. I have to roll Dahl's book. So there we have two planes, ABF and BFG. You could name other things. You could have called the blue one AEF or ABE or something like that. The green one could have been BCG, BFC, anything like that. So the next question says, why do you only need to find two common points to name the intersection of two distinct planes? I want you to pause the video and think about that on your own so you can come up with any answer. And when you've got something, press play again. Really, the answer to this comes from postulate 1.3, which says if two distinct planes intersect, they intersect in exactly one line. Well, the only reason you need to find two common points to name the intersection is because the intersection is a line, and you only need 2 points to name a line. You can say intersection is a line, and you only need 2 points to name a line. And there you have it. Got a little more to go here. Our last page is postulate 1-4. It says through any three non-collinear points there is exactly one plane. If any of you are photographers, you've ever used a tripod, the reason why you only need a tripod, 3 legs, is because that makes your camera stable. And that's because your camera is sitting on a plane. Sometimes having a 4th leg doesn't mean your camera is any more stable than it is with 3. If you look here, points Q, R, and S are non-collinear, so plane P is the only plane that contains them. So here we have our last few problems of the day. It says, using the point plane postulate, part 4, which we just talked about, what plane contains points N, P, and Q? Shade the plane. What I would do to start with is find those 3 points. N, P, and Q, and then you want to look at where on that box those 3 points are and shade them in. If I look, well, if I'm going to connect them, it looks like it's the bottom of this shape, just like that, and there you have it. There's the plane. I'd like you to pause the video and try the next one on your own. This problem is a little bit more difficult because those 3 points, I have them all traced in blue for part B, they're not a side of this this box, and so if you look, what I like to do is I like to connect the points that make up the plane. So right now I have those two segments that are created. And if you look, the other point that's going to follow that pattern is P. So I'm going to add P to that. If you connect all 4 of those points, you're actually going to now have your plane. And there you have it. There is the plane that all 4 points lie in. There are 2 more questions that go with this problem. It says, what plane contains points L, M, and N? Shade the plane in the figure above with another color. And then, what is the name of a line that is coplanar with J, K, and KL? Pause the video and try these both on your own. You can see my answer to the first one in red. L, M, N, and P also lies in that plane, so I shaded that in red. I then took the 2 lines in the next problem, J, K, and KL, and I traced them in black, so you can see where they are and where they intersect. So if you're looking at those 2 lines, you're trying to find something that's coplanar. So it might help to figure out what plane that they're on. If I'm looking at both those lines, they're both edges of the top. And so this is the entire top then. So any other 2 lines on that top would work. We could say JM. We could say LM. We could even say something like MK. That's another line that is coplanar. Or JL. There's lots of options. Those are the 4 other lines that I can see up there right now that are coplanar with those. So this is actually the end of lesson 1-2 part C of geometry. The objective for today was to understand basic terms and postulates of geometry.